this tutorial looks at trigonometric basics. So by the end of this presentation, you should be able to name key features of triangles and apply trigonometric ratios to solve some triangles. You aren't actually looking to do the full solve in this tutorial. We're just looking at finding the right ratios to use and how we can use our calculator to solve some stuff. So, first step is always to name your right angled triangle. So opposite the right angle is always your hypotenuse. This is also always the longest side of your right angled triangle. So that is your hypotenuse. And then between your angles, so your A's, your angles, is your adjacent side. Adjacent actually means next to, basically. So between your angles is your adjacent side. And then that leaves you the opposite. So trigonometric ratios, there are 3 of them. So there is sine, cosine, and tan. Note sine and not sin. It is sine. So sine is the trigonometric ratio for opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We use the way to remember this, I suppose, is so, car, toa. So, S-O-H, car, C-A-H, toa, T-O-A. Hoping you're recognizing sine, O-H, cos, A-H, tan, O-A. So, car, toa. So, for example, we're asked to write the ratios for sine, cosine, and tangent for the following triangles. So when you go to do this, your first step is always to write out your, label your triangles. So label your hypotenuse to start off with. It's your easiest side to label. And then depending on where your angle is, we label our adjacent and our opposite sides. And then it's a substitution. So sine theta equals opposite over hypotenuse, which is 35 on 37. Cos theta is adjacent over hypotenuse, which is 12 over 37, and tan opposite over adjacent, which is 35 on 12. Red box your answers. And next one. So label your triangle. Hypotenuse is a 20. Depending on where your angle is, your adjacent in this case is 16, and then that leaves your opposite as 12. So sine theta is opposite over hypotenuse, 12 over 20. Simplify any fraction that you might have. Cos theta adjacent over hypotenuse, 16 over 20, 4/5. And then tan theta is 12 over 16. And red box your answers. Example 2 asks us to calculate the following trigonometric ratios to 4 decimal places. This is a CAS question. You are going to have to check your CAS to make sure that it is in degrees. So note that you can do this a few different ways. Up in this top corner, it should say RAD, DEG, or GRA. You want to be in degrees more often than not. So as soon as you have a degree symbol, you wish to be in degrees. In order to change your calculator into degrees, you click Dock, and then we're going to Settings and Status. So Settings and Status, Document Settings, and then change the angle to degrees. There is radians in that, and there is gradians. We won't ever use gradians. You may come across radians at some point, but more often than not, we're looking at degrees. I'm going to make this default. And then note in my top corner here, I've highlighted over it and you can see degrees is written there. So my calculator is now in good degrees. And then I'm going to do each of these calculations. Use the trig button, so below control as trig, and then just type in your angles, so 54.23, and then equals. Now, my cos question there, cos 19, because the number I've input is not a decimal, it is just popping out with the same answer. So control enter, and I get out my decimal answer of 0.9455. 4 decimal places, done. Next question, tan 99.1, gives me out negative 6.2432. Red box my answers.